Okay, here we go with the Sparky cube. I'm going to create a polygon plane for the ground. Gets bigger, gets longer, and I like to have nice even square divisions. It's just me being paranoid, so there we go. And then freeze and delete. Cube. So create a polygon cube. I'll make it a little bit bigger. Freeze and delete. May as well name this ground and cube. The ground becomes A, so let's go to FX. Becomes under N particles, fields and solvers, legacy, passive rigid body for the ground, and active rigid body for the cube. And the cube will get picked up and moved to the back. And we need to add some gravity to this so it will fall. So with the cube selected, fields and solvers, gravity. I like to see the gravity, so I'll pull it up. We'll leave it at its default 9.8 magnitude, and we want this dude here to go forward, so I'm going to select it and go into rigid body 2 and go initial velocity in X, and I'm going to say, I don't know, 15. Oh, 156 would be crazy. 15. All right, and then we will always want to make sure that our settings are play every frame, and then it's limited to real time, so it doesn't go any faster than that. And if you want to just keep track of what's going on, I can go to, they keep moving this stuff around. Yeah, display, heads up display, frame rate. And then down here in the bottom right hand corner, it will display whatever the frame rate is, so you can get a sense if it's playing in real time or slower or whatever. And then I'm going to hit play and I'm going to see what happens. Whoa! Boom, bang, bounce, super boring. Don't have enough animation frames. Let's go to 300. And yay! So it comes, kind of hits the thing, bounces a few times, comes to a stop. Pretty boring. Going to rewind that. I want to give it some spin and Z of, let's say, 20. And then that way it's going to kind of hit point on the side and bounce around a bit, and it's going to fall off the end here, so I'll rewind this and say, you know what, you should have a spin of 30. Not 20, 30, just 30. And, oh, it's playing backwards. I hate that. Stop. Rewind. Play. Oh. Stop. Rewind. Play forward. It's kind of boring because when mine rotates, it kind of see it's rotating and landing on that edge there. So maybe I'll have it forward a little bit, which would be an X rotation. So let's say 10 in X. No, let's do 30 in X. And let's see now what it does. So, no, she's a tumbling. She's a tumbler. Stop. Stop. And, yeah, maybe I will just check where this hits the ground. Stop, so you can see it can go a bit forward. And I think maybe I'll slow it down a little bit. So it's velocity. So, ooh, yeah, well, let's see at 12, but I'm a bit worried it's going to miss the plane now. Ooh, just barely. Nice. And comes to a stop. Pretty nice. So actually, since that's much slower now, I can pull that back. And one last check. I do want to get a bit of a slide on the end. Oh, pretty good. Yeah, slides on one side. Pretty nice. Okay. I can live with that. Pretty happy with that. Okay, doesn't matter what it looks like, as long as it does a bit of bouncy, bit of tumbly. Don't forget we can play with the mass, the bounciness, the dampening, and the dynamic friction. Dynamic friction, static friction. To speed it up or slow it down, or less bouncy, more mass, whatever. Anyway, you can play with it all you want. what I got here is okay. I've got a hit, I've got a tumble, I've got a bounces back, slides, and then comes to a stop. Cool. And it's playing around 24 frames a second, so it is a bit slow, but that's 24 frames. If we wanted it to go faster, we'd have to adjust the speed and all that stuff. Okay, so now that we've done that, what we want to do, the whole goal of this thing, is that anytime the cube hits the ground, boink, then it should throw up some dust or some sparks. So what we need to do is we need a way to mark each contact position. And so if we grab the cube or the plane, doesn't matter, and then we've been working with rigid body 2 on the cube, just scroll down here, go to the rigid solver under inputs, and make sure that the contact count is on. So contact data should be on. So you just type a 1 in there, hit enter, that turns it on. Remember, in my Boolean is an on, off, true, false, yes, no, 0, 1 thing. So contact data is on, so now we can actually query rigid solver 2, which is this rigid solver on the cube. We can ask it wherever it makes contact. We can ask it how many times it makes contact, and we can ask it where that contact position is. So to do that, I'll just open up the little script editor here, and I'll make this a bit bigger, and I'm going to create a new tab mel. And in here, I'm just going to give myself a few lines, and I'm going to type rigid body, which is the command. I want to query or ask a question, and I want to ask it the contact count, and I want to ask that for rigid body 2, because that's the one on the cube. Always finish with a semicolon. So this is going to return contact count, which is the number of contacts. Going to erase the upper portion and make sure that I have echo all commands on under history. Highlight the line, highlight the line, hit play up here, enter on the number pad, and oh yeah, capital B. Be very careful with that. So rigid body 2, then get an error up here. It says no object matches name rigid body 2. That's because I didn't capitalize the B. So now that I've capitalized the B, I can see the result is 0, and of course it is 0. There's no contact because the cube is up in the air here. So play it out until it hits the ground, and you're sure it's on the ground, and you have to be pretty sure. So right there, I'm pretty sure. I'll just clear the upper portion again, and I will hit play. And I have 6 counts. So I know that it's actually in contact here. So let me just switch that to CP. So CC is contact count, CP is contact position. So this should read out 6 contacts times XYZ. So that's 3. 6 times 3 is 18. So when I do that out, I should get, make this a bit wider, you know, I've got 18 numbers here. Or probably, I'm not going to count them. So the first 3 are XYZ here. So that's the first contact position, -1.5 in X, pretty much 0 in Y, and 10 in Z, positive 10. So the issue here is that it's really not usable in a spewed out in a series like this, so I'd rather it was listed down in a series of rows, 3 columns, X, Y, Z, and then a bunch of rows. So what we'll do is we're going to start our little script here. We're going to create a string, and the string is going to be called CP, which is contact position, and then 2 square brackets, and that's going to equal this, whatever this command returns. And to capture the return, so to capture all of these 18 values or whatever they are, we've got to use the back quote. The back quote is the tilde key, so above the tab and to the right of the number 1. It's below escape. So back quote, and if you control middle mouse the wheel here, you can make the text bigger in the script editor. So what'll happen now is when I execute this, it'll return the 18 numbers, but it's taken these 18 numbers and it's read them into this new string variable that we created. So now if I just do a for loop, so for $i equals 0, semicolon, $i So the first bit is initializing, the second bit is as long as $i is less than the size of our list of numbers. So that's $CP, semicolon. And then we have to up the counter every time. So $I plus plus, and then close your regular braces, open a curly bracket, and hit enter a few times. And then I just want to do a print command just to make sure that it's printing these numbers out. I want to compare them because we're going to have to convert these strings, which are text, into float values. And I want to compare that the input, the string values, are the same as the output, the float values. So I'm going to put a print command in here, and I'm just going to say print the $CP. So $CP and $I inside there so that it iterates through the list. And then we're just going to add a new line so it jumps down a line every time. And then I'm going to close the brackets and then semicolon at the end. Okay, so what we would do here is we've got the string and then we've got a for loop. So $, anytime you see a $, you know that's a variable. This is just a counter variable, the I. So I starts at 0. We're going to run this loop as long as I is less than the length of our list, and then every time through the loop we add 1 to whatever the number is. So the first time through the loop it's 0 because that's what we initialized it. So it's going to print out CP0. CP0 would be the first 3 numbers. Then it's going to add 1 to 0, which is 1. It's going to check is 1 less than, in this case, 18. Yes. Then it's going to print out the next series, well, 6 actually, 6 contact points. So yes, and then it just keeps going through that loop until it adds 1, and then it checks is 6 less than 6, and it's not, it's equal to 6, so it kicks out. Okay, so anyway, so we highlight everything this time. I'm just going to clear the upper portion again. I'm going to hit execute, and it always prints out your command that you were running. So there it is. And then it gives me the results. So you can see here I have 1, 2, 3, 4, 5, 6 contact points, X, Y, Z positions, where Y is 0.01, which is pretty close to 0 because we didn't really raise this off the ground. And so there we have it. So there we have our beautiful printout of 6 positions, and we know where each of those positions are, and now we know that at each of those points we just need to have a way to mark that or create an emitter to emit the sparks from each of those points. So luckily enough, what we can do is we can just use the emit command, and we can emit a particle at each of those positions. And because we can emit from objects, meaning we can emit particles from cubes or planes, we can also emit them from other particles. So what we'll do is once we've got these particles down on the ground, we'll just say emit from object, and then our sparks will be emitted from each of these points because there will be a particle there. Sure, so let's give that a go. So what we need, first of all, I'm just going to minimize here. I'm going to go to end particles, and I'm just going to say create emitter. It doesn't matter what we're doing. We're actually doing this just to get a particle shape. So I'm going to say create emitter. Done. I'm going to go to the outliner. And when I create an emitter, Maya automatically creates a particle shape node here that attaches to the emitter because we need to emit particles into a shape. So we don't actually need this emitter because this particle shape is what we're going to use to emit the particles at each of the contact positions. So just take that emitter and delete it. And we'll call this particle, let's call it, I'm going to go contact position particle. Okay, contact position particle, or maybe just contact. We need the POS, so contact particle. That makes sense. So we have the gravity field, we have the contact particle now. So the command to emit particles is, it's literally emit, and then you just tell it which particle shape you want to emit the particle into, and its XYZ position. So if we go back to our script editor, in here, I'm just going to comment out this print command. I'm going to keep it because I may want to check data and whatnot. So 2 front slashes will comment out the line. The line goes red, and basically Maya ignores everything that comes after the comment. It's a way for us to actually leave notes to each other or to yourself to say, oh, this next bit of code is going to do this, that, and the next thing gets a variable from over there and does this, that. So if anybody else is going to use your script and they want to know what's going on, you can leave them a note, or you will probably forget what you've done in a year or two, and it'd be nice to have some notes in your own script. I just use it to get rid of lines that I don't need anymore, and then when I'm done and I know that the script is working, I just go and I remove them. So anyway, so let's do an emit here. So I'll just come down here, tab over, backspace a couple times, line it up. Oh wait, no, just use the tab. There we go. So emit. And again, anytime you see, like if you type something in the script editor and it goes blue and it's italicized, that's a command in Maya. So size is a command, rigid body is a command, emit is a command. That's how you can tell them. The variables are going to be in green, and any kind of control loops will be like for and if statements will be in green as well. And then the text, of course, goes in yellow. So anyways, emit from which object? So -O, and the object's going to be contact particle. And then you need to tell it its position. So what is the position? So here we run into a bit of trouble because the position is it's asking for an XYZ position, and unfortunately at the moment we don't have the position. So we've read out the position up here at the top. We know that there are, wherever it is, let's see, I'll just clear the top and rerun this. So we have these numbers, so we know the positions. Unfortunately, they're string, so we can't just sort of say $CP. Well, let's try it. I don't know, I couldn't get it to work before. So $CP, and then let's say 0, just because. So this is 3 numbers that we know, 1, 2, 3, and this is looking for 3 numbers. And if we run this, we'll probably get an error. It says error while parsing arguments. So what it's looking for is it's actually looking for 1, 2, 3 numbers. And what we're giving it is a number that's made up of 3 components. So it doesn't really know what to do with that. We need to give it just this -1, and then just the 0.0, and then just the 9.9. So we need to take this string and we need to convert it to a float, like an actual number. And then we need to break that into its sort of constituent parts, X, Y, Z. Does seem kind of roundabout and ridiculous, and it is kind of roundabout and ridiculous, and it's because in Mel we can't define dynamic matrices. So Maya gets around it by defining this return position value as a string. It's just a series of text, and then what we have to do is jump through a couple of hoops to break those pieces out. Whereas this is going to be dynamic. It's just $CP. It could be nothing, or it could be a million numbers. We can't actually define this matrix, this 3 by 6 or whatever, as dynamic. So this is always a bit of a workaround. Anyway, so what we're going to do is we're going to use this for loop, and we're going to do a bit of this. Well, anyway, let's just see this bit of this weirdness. So let me come down a line here. And I'm just going to type, I like to make some white space. So we're going to create a temporary variable. So this is going to be the temp position. And it's also a string, and it's also a list. And then after that, we're going to use this command called tokenize. So tokenize is a way to just break up a series of text into constituent parts. So what we do is we look for a divider. And we know that there's a number here and it's continuous, there's no gaps, and then all of a sudden there's a space. So it could be a comma, it could be a backslash, it could be whatever. In this case, each of our numbers are separated by an empty space. So we're going to tell this tokenize command to search the $CP, $I. So that's our list. We're going to tell it, so that's the list that we're searching, and we're going to search for a empty space. So just put in like an open quote and then hit the space bar and then a close quote. So we're actually looking for nothing, like a gap. And then once we find a gap, once this tokenize finds a gap in this list here of 3 numbers, it's going to read all these numbers out, and then it's going to hit a gap. And so we want to take whatever it's read out, this 1.573399, and we want to put it into this temp position. So $ temp position. And then close your regular bracket, and then always a semicolon at the end of the line. So, and then once we have the 3 numbers, XYZ positions read into our temp position, we just need to redefine those into a new variable. So float is what we want because we want a number, and then we have the $x position, and I'm just going to copy this because I don't like to type a lot of stuff. So Control V, Control V. And this is the Y position, and this is the Z position, and it's equal to temp position 0. And then I'll copy that. I guess I could have waited and done the whole thing. That's fine. So Control C, Control V, Control V, and this 0 is now 1 because we want the second position, and then the third position. So we've got a string, created this temporary variable. We use this tokenize command to strip the 3 elements out of this sequence of text, read it into this temp position variable, and then we read it out of this temp position variable and say the X position is the first number, the Y position is the second number, and that's a typo there, and the Z position is the third number, which is, remember, the lists always start counting at 0, so the 0 position, the 1 position, and the 2 position. And then once we've done that, we should be able to come into our emit command, sorry, and instead of giving it the $CP, we just give it the XYZ position. So let's go X position, let's copy that, and we'll paste it in here. So Control V, Control V, Control V. So X, Y, and Z. Okay, so then let's give it a go. What I'm going to do is I'm going to put this print command back in, and I'm also going to put in a print command. So I'm going to copy this, and I'm going to say print, and I want to print these XYZ positions out. So Control C, and then Control V, and then to print 3 things out, you've got to add them together, if you will. So I'm just going to go plus space and plus, and then let's do a new line there, and then close a bracket, and then semicolon. So what this will do is it'll print out this one, and I should probably put something in here so I can tell the difference. So I'm going to go just open a quote, and I'm going to say, I don't know, original, right, number, and then this is, or maybe pre and post. So let's just go pre, and then in here I'll do the same thing. So, oops, and then close the quote. So space, close the quote, plus sign. And then this is going to be post. So in other words, pre-conversion, the raw number, and then post-conversion, the float. Or I guess we could have put string. Maybe that'll be better. That's more clear what's going on. So this is the string, and this is the float. And colon space, and there you go. And then add the plus sign. So it'll print out string, and then the string number, and then jump down a line, and then it'll print out the float number, and then the float numbers, and then each of these probably should be separated by a space. So it's a bit weird, I know. So what'll happen is in here I've got to go plus, an empty space, plus. So now I'll just copy this and paste it here. So it's going to print out the X position, a space, the Y position, a space, and then the Z position, and then jump down the line. I'm ready for the next round of the for loop. So what it should do is let's clear the top portion. Let's highlight everything. Let's execute that. And if everything went well, it should turn out, so now we can check. So there's our string value. Is it exactly the same as the float value? And it is, etc. So now we know pre-conversion we had this position, and then we did our tokenize and all that, and we've checked it, and we can see that each of those numbers match. So 2 by 2 as they go through here, string float, string float, string float, no issues. And then I'm just going to minimize, because what I should have now is if I select the particle shape, I should have now a little square shape here. This is where the particles have been emitted into. And if I go to empty space and right mouse click and go to particle, so I'll harp on about this because I still see people doing this in second semester a lot. They want to get to the components of the selected object, and so they hover their mouse here or here or here. And Maya is going to review a context-sensitive marking menu depending on what's under the mouse. What's under the mouse right here is a polygon cube, not the particle. So if you do it there, you're going to get edges, faces, and vertices, not particles. And you're going to do it here, and you're going to get edges and faces and particles. So Maya is going to read what's under your cursor and give you the context-sensitive marking menu. So imagine you're rigging something. You've got geometry, you've got joints, you've got an IK handle, and you just randomly put the mouse over something and right mouse click, even though you've got it selected. That's not how this works. So you select it, and if you want to get to the components of the selected object, put your mouse where there's nothing under the mouse, just empty space, and right mouse click, and you will always get the context-sensitive marking menu for the selected object. If you select something and then come in here and put your mouse over here, it's going to give you one for whatever the mouse is over, in this case the plane, which happens to be the same as the cube. So select what you want, put your mouse in empty space, and you will always get to the components of, or the context-sensitive marking menu for the selected object in the outliner. Okay, so anyway, now I can see I've got however many particles. It said 6, I think, so I don't know where the other 2 are. They're probably around somewhere. So, but I can see there are some. So I know this is working. So the script is, as it stands, functional. I don't need to check the print stuff anymore, so I'm going to comment that out. So 2 front slashes, which is the same key as the question mark, because I don't need that spewing data into the script editor. Okay, so the issue now is this works at 1 frame. We'd have to run the script every frame. That's exactly what an expression is. It's just a way to execute a set of code, an expression, a script, every frame. So let's give that a go. So I'm going to highlight everything here, copy it. Probably can turn off echo all commands, I think, for now. I'm going to close the script editor, and I'm going to go to the Windows Animation Editor, Expression Editor. That's going to open up the expression editor. I want to create a new expression. So this is going to be contact. Let's go contact particle, and then I'm going to go underscore exp for expression. So now I have contact particle expression, and I'm going to just do a by expression name. Oh, I didn't hit create. So anyway, so I filtered by expression name. That's fine. I'm just going to type this back in here. So contact particle expression, paste into the expression part, and hit create. Then it creates the expression. So what this is going to do is this is an expression. It's going to run every frame. Once you hit create, it should just pop out. It should give you a result. It shouldn't give you any warnings or anything. And then the create changes to edit. So it's in, it's good, it's ready to go, and I'll just close that, and I'll zoom out a bit, rewind. Let's just make sure I'm in object mode, and I'm gonna hit play and let this play out. And then you can see it dropped a particle, dropped a particle, dropped a bunch of particles, and it comes to a stop. And it'll keep emitting particles because it's technically in contact. So eventually that's going to be a problem, and we'll have to come up with a way to have it stop emitting particles at a certain point, because once the cube comes to a stop, it really shouldn't be doing that anymore. So there's that. But anyway, so it's working, right? So I've got I've got these particles going out, and again, if you want to right mouse click an empty space, you can go to particle, and then maybe they turn blue. It's a bit easier to see what they're doing. So boinky boinky boom 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 boom, and then slide. Cool, so that's all good. So nice. So now what we want to do is that we have that particle shape. We just want to tell Maya to emit the sparks, the new particles, from those current marked particles. So in the outliner, I'm just going to grab contact particle, and I'm going to go up to particles. I'm going to go back into legacy, and I'm just going to say emit from object. And bingo. That should do it. So this is now going to be spark particle. Okay. And then under contact particle, there should now be an emitter under here. So we can just call this spark emitter. Let's do that. Spark emitter. Cool. And when we hit play, we should get boom anywhere there. So there's particles going up. There's another particle going up. There's a bunch of particles going up. And particles, particles, particles being emitted in all directions. And oh my goodness, particles, particles, particles. So functional just doesn't look good. So now we're going to go in and we're going to just play with stuff that we've talked about over the past couple of weeks, which is, you know, we can change the points to streaks, and we can, right now it's an omni emitter, so we probably want a directional emitter, and we can tell them to collide with the surface and give it some gravity and all that stuff to make it look good. The first thing, though, to make note of is that these particles live forever by default. So when it first makes contact with the ground, boop, it emitted a bunch of particles. But by now already, 1-2 frames later, it really shouldn't be emitting any more particles, because it's, you know, makes contact and you get a puff of dust or you get a few sparks coming off. But that's not what's happening. This thing is emitting, 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 because it lives forever. So the first thing I'm going to do is I'm going to turn off my my contact particles. I'm going to change their lifespan to be something super tiny short. So in the attribute editor, under spark particles, no, I want contact particles. So contact particle shape, live forever, no go. Let's maybe just make it a constant, and let's just say something super short. So this is 1 second, which is 24 frames. If I want them to live 2 frames, I could say 2 divided by 24 is like 0.08 frames, so 0.1 frames maybe. Right, so that make them live 0.1 of a second, and that should help. They won't be emitting particles quite so much. So let's rewind that. Let's set that up, let it go, and then boink, and then you can see it just emitted just those particles. A few particles are being emitted, a few particles are being emitted, so many fewer particles. Still the issue with it emitting particles once the cube is stopped, but many fewer particles are being emitted. So that's just because of the lifespan. They're only allowed to live a very short period of time, and that's working out pretty well. Okay, so that's it for the contact particles. Now on the spark particles here, we want to do the same thing. I don't need them to live forever. I'm going to random range this, and 1 second is 24 frames. Yeah, it's probably a lot. So again, the sparks probably don't have to come out much more than maybe twice as long as they're alive. So maybe 0.2, and then give it a random of 0.1. And we'll see how that goes. Also, I would like them to not be points. I would like them to be streaks. And then to get at the attributes for the streaks, you have to hit the current render type, and it'll load those in. So let's just get some so we can see what happens with them. So boom, boom. They're it's actually not that bad. So they're throwing out some sparks there, which is pretty good. I actually don't mind that. Seems reasonable. It's still emitting as an omni, so in all directions, so we can fix that. That actually doesn't look too bad. So what I'll do is, before I play with the tail length and tail fade and that, I'm going to change the color so that it's easier to see. So I'm going to scroll down here into the per particle array attributes, and you can see there's nothing in here that allows us to control color. So we're going to add one. So just click the color button here on Add Dynamic Attributes, Color. We want a per particle attribute, so it's going to allow us to change the color per individual particle. Now we have an RGB PP that shows up, so red, green, blue per particle or color per particle. Right mouse click in the empty text box, say create a ramp. We don't need the options. The default is attaching the color to age, which is going to work well for us. And then we want to adjust that ramp. So right mouse click again, array mapper out PP, edit ramp. And it's a black and white ramp, so we're going to flip those over. And we're going to say we start out sort of whitey blue. We're going to move to a sort of a yellowy orange. No, yellowy orange. And then we're going to move to like a orangey red. And then once, you know, the cinder burns up or the chunk of metal, it's going to turn into a piece of ash, so it's going to go black. Fine. So there we go. Let's try that now. I'm going to hit play here and wait for it to come into screen. Bang. So it's okay. Maybe just so we can be a bit more dramatic, maybe I'll make them a bit longer. So I can come in here to tail size, it's 1. So if we make those a bit longer, just so it's easier to see them. But to be honest, it doesn't look like they should really be much longer than that. Anyway, we can make it dramatic, that's fine. It doesn't have to be super realistic. We're not doing this for an actual show or film or anything. So maybe I'll make the tail size 4. Let's make it easy to see. I'm going to change the emitter. So spark emitter. It's an omni, so it should be directional. And the direction should be, it's set to X. So we're going to make the direction Y and Z. So it's going to go up and back, so 45-degree angle, so it's going to kind of come out the back a little bit. So let's see if that changes the look at all. Should do a little bit. Oops. Sorry, not Z, negative Z, so -1 on the direction, Z direction, because they're going forward. That looks kind of weird. So boom. You know what? It looks kind of weird. Let's try just up. Oh, you know what we haven't done yet? Yeah, that's a problem. That's why it looks weird. So definitely -Z. But we haven't given any spread. So let's give it a lot of spread. Let's go like 0.7 on the spread. And because they're all going in a perfectly straight line, so now this should help. So yeah, that's a bit better, right? Yeah, I'm digging that. Can make them faster, and maybe a few more particles. Let's see what that looks like. Yeah, now it looks weird. So I'm going to go back to 100 particles. Now that we've sped it up, we probably should shrink the, should shrink the tail size. So back to particle shape. Anyway, this is all up to you. You don't have to do what I'm doing. You can make them look however you want. I just think it looked kind of better before I started fooling around with it. Sure, maybe even just 50. Okay, so whatever. It looked better before, but anyway, I just want something that I can see. The other thing is they're going straight. They should really arc. So we need to put some gravity on this. And we don't want to use the same gravity because the gravity we put on here works pretty well for the cube. So if I change this gravity to really put a bend on this, then I might affect the cube animation. So with the spark particle selected, I'm just going to create another gravity. And this gravity I'm going to make actually quite a bit more. So maybe 20 on the magnitude for this gravity. It's really, I want these particles that are moving quite quickly to bend quite a bit. So let's go back and let's right in, and then we can. So now you can see they are arcing back, which is going to make them look a bit more realistic. Right. We should probably tell them to collide with the ground. So you see their emitter is right on the ground plane here, so that we want them to emit with this surface. So select the particle shape. So this is going to be so this gravity here, we could call this cube gravity, and then we can call this spark gravity or sparks gravity. Just so we can tell them apart. What was I doing? Particle. Oh yeah, so the sparks should make contact with the ground. So select the sparks, shift select the ground, end particles make collide. And then the issue there is if the emitter is actually below the ground plane, it might still emit below the ground. So I'm going to rewind this and play it and see what happens. Yeah, so a bit of a worry. So you can see it's. So what that's doing is probably it's only emitting a few of the sparks above the plane. So we're going to change the min-max value on the emitter. So on the emitter, we have the ability to set the min distance and the max distance. So I'm going to maybe set this to 0.1 and 0.2 in the direction, right? So this should emit the particles above the ground plane, and then that way they won't get trapped underneath. I'm hoping. I might have to increase those numbers. I don't know, until it looks all right. And then if you go too far, it might look kind of weird. So you can see what it's doing now. There are still a few being emitted under the ground, but I have more at the top now. So I think that's okay. And then I have some of these, they're hitting the ground and kind of bouncing off of it a little bit. So we could raise it a bit higher and maybe change the tail size, because the tail size may be too long, but I think that's acceptable. It still looks like it's coming out of the contact with the ground, and we have a few below, but we're probably not going to see them. So I think we're good there. So I think we got the look down. What we do probably want though is right, it should emit quite a few, because the greatest velocity here is at the front, at the beginning. When it hits the ground, it's moving the fastest, bang. And so you think more particles there, less, and then less, and then it should probably stop before the cube stops, and obviously it should be stopped now that the cube is stopped. So we'll want to modify the expression so that we can adjust, say, number of particles being emitted, and get it to stop as well, probably. So let's see what we can do about that. So let's go back to our expression editor. So Windows, animation expression editor. Select filter by expression name. You'll see it, and then it should load. I want to link the emitter rate to the velocity of the cube. And then I also want to say maybe if the velocity drops below a certain speed, then maybe it should stop altogether. And maybe you could link lifespan to velocity as well, so the lifespan gets shorter, as what we'll see. So let's start with the velocity. So for the velocity, I just want to create a new variable. So this variable is a vector, because velocity is actually made up of 3 float values, unlike our original matrix, which we had to use a string for. So vector, $, and we'll just call this velocity, and that's equal to, open a back quote, the rigid body command, rigid body. What did I spell there? Rigid, no D, rigid body. Weird. I want to query the velocity of rigid body 2. And then back quote, semicolon. Okay, and what we can do is maybe we'll have that just do a print command for us, just so we can print it out. We can see what the velocity is. So print $, velocity plus, and then we'll do a new line. Cool. Let's try that. So hit the edit button. It should say results, unless it says expression invalid after edit. Then you got to figure out how you mistyped inside yours. Mine's good. So this is just going to do a print of the velocity. So I'm going to close this. I'm going to open the script editor. I'm going to wipe the upper portion here. Let's move this out of the way a little bit. And then let's just hit play. Oh, execution error. No object matches name velocity, line 0. Really? Weird. Window, animation, expression editor. Oh, I forgot the dash in front. So you have to put the dash in front to tell it it's a flag, and then hit edit. It's funny that it allowed that to go through. Should have given me an error. Anyway, so let's try that. So let's clean up the top portion, rewind, let it rip. And so we were getting an X, a Y, and a Z velocity. And let's move this over. I want to see a bit more of the screen. And then let's keep playing that forward. So we can see that it's down to a velocity of 1.3 or so in Z. That's the one we're really concerned about. I don't really care about the Y or the X velocity. So yeah, let's try that again, and then maybe we can gauge where we think the particle should stop. So spray, and then even about there, we're down around 1 or so. So I think if the velocity goes below 1, we really shouldn't be emitting any particles anymore. Okay, so let's see if we can do that. So into the expression editor. And what we can say is this loop here really shouldn't run, 1, if there's no contact. So we should save a bit of calculation time. Expressions are the slowest evaluating things in Maya. So as opposed to connection editor or constraints or shader utilities or anything like that you can use to rig up things or connect things, expressions are the slowest. So if you have a lot of them in a scene, you're running a lot of things through expressions, your scene will probably slow down, and then animators will complain. So what we'll do is I'm just going to go above this line. I'm going to put an if statement. So I'm going to say I need a new variable. This one's going to be I think it's a string. Or is it a string? I'm going to check. I don't know. Oh, it doesn't. Yeah, so let's put a string in there. So string $ contact count, and I think it's just a regular old, might be I'm going to put integer and see whether it gives me an error. So integer, because really contact count is a whole number. It's either 0, 1, 2, 10, 5, 8, whatever. I'm going to make it equal to this rigid body command. I'm going to just, so I don't have to type all this out all the time, I'm going to copy it and I'm going to paste it in here, and it's contact count that I'm worried about here. And I'm going to hit edit and see, yeah, so expression invalid after edit. I don't think we've got that right. So to check that, I'm going to highlight, oh, yeah, but I haven't finished yet. So let me finish first. So if $ contact count is not equal to 0, that's when we want to run the script. So if the contact count is 1 or more, it'll actually run the script and emit a particle. But if the contact count is 0, then it's not going to bother going through the script, so it'll skip all of that. So that, could save us a bit of time. As well, though, I don't want to emit a particle if the velocity goes below, the x velocity goes below 1. So let's say and $velocity dot z has to be greater than 1. And then we have to close the regular brackets, open a set of curly brackets, and then just for readability, I'm going to end up tabbing every line up, down. So I'm just going down arrow and then hitting home, and then tabbing over, home, tab over, down, down, tab over. And actually this doesn't have to, oops, let's go enter. That doesn't, because we've, I think actually we don't even need these, so I'm going to get rid of them. There we go. All right, so now let's see if my expression is invalid after. So I believe this is probably the wrong thing. It just says syntax error here, expression invalid after edit, so 18.1. It'll be easier if I just highlight this, copy it, come down here, repaste it, and then execute it. So clear the top portion, execute it, and it'll tell me, so 256 CP, oh, what? Redeclaration, 246. I haven't redeclared CP at line 1. I don't know what it's talking about. Oh, I've forgotten to close my curly brackets. Sorry, that could be it. So for the if statement, I opened a curly bracket, and then I need to close it. So this needs to tab over, and then I need to do another one. So this curly bracket is a closed curly bracket, lines up with the if statement. There's the open curly bracket. This closed curly bracket lines up with the for statement. There's the open. So they've always got to pair up. So fingers crossed. If I execute that, I'm still getting a redeclaration of $CP. Okay, let me figure this out. I'll come back. Well, okay, so I don't know what caused this, but Maya, I think, has gotten confused. So what I've done is I've just changed the string variable name here to con position for contact position, and then I had to change it again here for contact position and here for contact. So there's 3 places where the CP, $CP was. Maya sometimes does this and redeclares the variable, and the problem is if you change the data type for the variable with the same name, Maya won't let that, because the CP variable is read into memory and it's there. I would have had to close Maya and then open Maya again, and then it might have worked, but instead I don't care. I just changed the name of the variable and everything seems to be fine. So it's a vector for the velocity, it's a string for the con position, and it's an integer for CC, which is the contact count. So con position needs to change wherever CP was, so that's in one place. I've changed it into the size place, and then I need to change it inside the tokenize. And then once you do that and execute this, check it, make sure it's still running, it should just return a whatever the the emit was for this one. It'll only do one. So I'm going to highlight that now, copy it, Control C, go back into my expression editor. So window, animation, expression editor, and I'm just going to repaste that into here. So V, and then hit edit, and it's fine. So I don't know, that's a weird one because you'd be chasing an error. There's no error there. That was just a weird variable naming issue in Maya, and that's pretty regular for me anyways. So it's good to edit, and I'm just gonna turn this off and close it, sorry, and I'm just gonna close that. And I'm going to rerun this. And so what we should get is, you know, might play a little bit quicker, but more importantly, when it runs to a stop here and the velocity goes below 1, it stops emitting the particle. So it's a bit abrupt, granted, because it's like particles, and then stop. Right, particle backer, particle, and then it's off. So I want to feather that a little bit. So the feathering, what I'm going to do is I'm actually going to have the rate of particle emission change as the cube slows down. So back to the window, expression editor, and we have the velocity already as a variable which we can read out. So it's not really part of this loop, but I am going to put it in the same place. And I'm just going to say, so what's the name of our emitter? Because I've forgotten already. Our emitter is called spark emitter. So I'm just maybe just going to copy that. So Control C, and I'm going to come into the window and I'm going to go spark emitter dot rate equals, and I want to tie it into the velocity. So I'm going to say $sign velocity dot z, because that's the velocity I'm interested in. I'm going to put this into brackets, and I know I started off with about 100, I think. So let's check that. 50 actually. And I know that my initial velocity on my cube, because I set it at frame 1, is 12. So if I have a velocity of 12 and I want to get 50 particles emitted, I would just multiply that by about 4.5. So if I come in here and I just say velocity times, let's make it 4.5, and then close the brackets, and then semicolon, we could say, okay, so 12 times, oops, just going to be 12 times 4.5. It's going to emit 54 particles at the beginning, but of course by the time it makes contact with the ground, it's going to probably be down even slower perhaps. So as the cube slows, it'll be, because this multiplication factor here, the velocity is going to drop, it's going to be emitting. So by the end, when we tell it to turn off the emitter, it's actually a velocity of about 1, so it's only going to be emitting about 4.5 particles from about 50 to the beginning. So it should just feather right off, and maybe too much, so we might have to, you know, you can go in here and adjust this multiplier, or maybe we got to get fancier with our formula. But anyway, I'm going to hit edit. Should say result, again, shouldn't say invalid after edit. And now we should have something that hopefully is a little bit cleaner looking. So it's going to hit and emit a few particles, and then, right, it's emitting particles and should be emitting less and less, and then it comes to a stop. So maybe not super dramatic now. We could also link the speed to the velocity. So I think, because that first one is really non-dramatic, this amount of, so watch, it'll hit, right? That's not a lot of particles there. So I don't know. I'd like to see more there. So maybe the speed of them will also change. Because once it's sliding, it actually looks reasonable. So that part's pretty good. Maybe the beginning part could be a bit fancier. So let's try one last goof around edit here. Let's get the outliner. Let's grab the emitter, and let's just check. So speed is 5. So that would be velocity divided by 2. So the velocity is 12 divided by 2 is 6. So speed is 6. Oh, we don't have any speed random. So let's do speed random about 2.5. I don't know, maybe I want them to go a bit quicker, maybe. So maybe so the velocity is 12. Huh. So multiply by 0.4. If I multiply by 0.3, so let's say 12 times 0.3 is 3.6. So 12, sorry, times 0.6, 7.2. Yeah, maybe. So maybe by 0.6. So what I would do, it's been an hour, so maybe I'll finish this up. But let's just put this one last thing on there. I won't tweak it or anything. I just want to see what it looks like. I'm going to also say that the spark emitter dot speed is equal to $ velocity dot z times 0.6, maybe do 0.6, and then edit. And again, should give you a result, shouldn't say invalid after edit, and boom. So a bit more velocity on that, a bit more velocity on that, and then yeah, now you can see, yeah, so it's actually emitting less particles and they're going slower. So quite a few. I'm thinking maybe the so it's emitting the particles. I think a few of them are going underneath. So I might just do one last thing, which is the min and max. I might change this to 0.2 and then 0.3. Yeah. Cool. Done. Looks good. I can live with that for sure. Sparks. I guess you can't even see them now. So the only thing would be, that looks a bit more realistic to me. Maybe just so I can see them, I'll just go to the spark particle shape here, and I'll just maybe make the line width like 2, and that'll just make them thicker. Not something I would actually do if I was, because now they look like little fettuccinis coming out of their linguinis or something, but yeah, I think that's all right. I think they're bouncing a bit too much, so that's the next thing. I think they're bouncing and hitting the ground and bouncing up again, and that's what looks kind of weird. So I could either play with the lifespan and things like that, or maybe the bounciness of the particles. They probably shouldn't be that bouncy. So on this plane here, this geoconnector. So you select the plane, find the geoconnector. The resilience is the bounciness. So if I made that say 0.2, I don't think they would bounce as much. Yeah, that's better. Cool, done. There you go. It's cube emitting sparks, and there's our fancy expression. Great, so I'll post that up and it'll be on YouTube. Oh, of course it's on YouTube. You're watching it right now. See ya.